Okay, so let's talk about the goal of functions. And let's start with an odd function that you're very familiar with. Let's start out with something like this. Say, okay, example 1, we want to evaluate the function f of x equals, let's make up something like 3x minus 4, where we know that x is equal to, let's choose 7. Okay, now the first thing to note is that there is a 1 right there, so we know this is a linear function. It has a 180-degree rotational symmetry, and we know that as it goes to the left, it should go to negative infinity, and as it goes to the right, it should go to positive infinity. Well, how can we evaluate specific points? Well, we know that x equals 7, and so what we can write is this. F of, let me even use a different color here, f of 7 is equal to 3, and wherever we see an x, we will always replace it with a parentheses. Now, what goes in place of the x? Of course, it will be the 7. Alright, so at this point, we now have f of 7. Our right-hand side never really changes. And we're going to say, hey, this is going to be equal to 3 times 7, which we know is 21, minus 4. And of course, what is f of 7? Well, we know that that should be, let's see, 21 minus 4 should give us 17. And so we now evaluated this linear function at a very specific point. More or less, what's actually happening here is we're saying, hey, let's see, it's positive. It's going to look something more or less like this. And we're basically saying, hey, if we go over 1, 2, 3, 4, 5, 6, 7, right here, and we go up, well, when we hit this point, we're going to a height of 17. And that's just kind of a way for you to rationalize what's going on. All right, let's try another example. Okay, so here we have example 2. Okay, and let's go ahead and do a quadratic function or an even function. Let's say we have f of x is equal to, let's say 3x squared minus 5x plus 2. Where, let's just go ahead and choose any number for x. Let's say x is equal to 4. Alright, so how are we going to write this? Well, everywhere we see an x, we have to replace that with a 4. So let me go ahead and write this equation first. I'll write f parentheses. And notice everywhere I have an x, I will either leave it blank or put a parentheses in there. So I'll do parentheses here where we have this x squared. I'll write parentheses squared minus 5 parentheses plus 2. Okay, and just using this red color again, everywhere we had an x, since we know that our x value is 4, we're going to plug in a 4. Now I want to make one note here, just a review from Algebra 2. Whenever you have something squared, you're really saying, hey, that number is being multiplied by itself 2 times. Okay, so 4 squared really means 4 is there twice. We're doing 4 times 4. Okay, what does this give us? Well, we now have f of 4. You know, I even drove all the way to DISC headquarters to get this computer issue fixed yesterday. And then when I got there, it completely worked. And so now it seems like it's back. So you have my apologies. But we know that 4 times 4 will actually give us 16. And here we have negative 5 times 4. Don't forget to include that sign right there. Negative 5 times 4 will give us negative 20. And then, of course, we'll add that positive 2. We won't do anything with that just yet. Now here is where you really might start needing a calculator. So if you want, I would just go Google Desmos calculator and use that calculator there. And 3 times 16 will, of course, give you 48. Now, how about negative 20 plus 2? Let's combine our like terms here. Negative 20 plus 2. Well, that's going to give us negative 18. And here we have 48 minus 18, and you should actually be able to do that one in your head. That one's pretty simple. So we'll have f of 4 is equal to 48 minus 18, which will of course be 30. Alright, so we're essentially making a prediction when x is 4, our y value is going to be 30. Okay, let's go ahead and do a couple more. Alright, example 3. Now this one will actually be, I think, a little bit easier, but there's one little twist that I want to include. So let's say this, and you know, let's even change it up. It doesn't always have to be f of x. Let's do g of x is equal to, and let's do 4x cubed, and let's say minus 7, where, and you know what, let's see, what do we want x to be? Let's choose a small number since it's cubed. Okay, so we have g of x equals 4x cubed minus 7, where x equals 2. Okay, so I'll just do what I've been doing. I'll rewrite the function, and everywhere that I have an x, I will leave it completely blank. And instead of x cubed, we write parentheses cubed. Okay, now we know that x is 2, and so in place of my x's, I put a 2. Let's go ahead and begin solving this. Now, one quick note. When we had x squared, that meant that the number was there twice. So when we have x cubed, that means that that number will actually be there 3 times. So since we have 2 cubed, we will have 2 times 2 times 2. And so let's go ahead and see, what does this start to become? We have g of 2 is equal to 4 times, let's see, 2 times 2 would be 4, and 4 times another 2 would be 8. And that's simply how you do a cube. Just multiply the number by itself 3 times, minus 7. Now here, we are pretty close to finishing. We have g of 2 is equal to 4 times 8, which is going to be 32, minus 7. Well, let's see, what is 32 minus 7? Well, of course, that's going to give us g of 2 is equal to 25. And since I have a little space here, let me even show you what this looks like. We know that we have an odd function, so it's going to look something like that. And we're saying, hey, x is 2, so I go over 1, 2. And these things grow so quickly that by the time we hit 2 and we go all the way up here, well, we've actually gone up a height of 25. And that's what that function is essentially telling us. Okay, well, I have one final example for you. And this final example should be fairly easy. Let's say this. Let's say example 4. And I'm going to give you two functions. So we have, f of x is equal to, let's say, 2x plus 1. I'm going to keep it very simple. And let's say I have another function, g of x, which could be, let's make it a little bit more challenging, negative 4x minus 8. Okay. Let's say I'm asking you, which one of these functions will give us a y? Let's say y equals, I don't know, 7, when x equals 3. So here's my question. Which function, f of x or g of x, will give me a y of 7 when x equals 3? And just remember, y is another way to write f of x or g of x. Okay, so let's take a look at f of x. We're going to say, okay, instead of f of x, we're going to plug in that 7 for the y is equal to 2 parentheses 3, because remember our x value is 3, plus 1. And some of you can probably already see this in your head. Let's see, 2 times 3 is 6, plus 1. And let's see, 6 plus 1, well, of course, that would give us 7. And so, yeah, this one checks out. In this case, f of x will be our answer. But let's go ahead and test out g of x. Okay, so instead of g of x, we know g of x is another way of saying y. We can say 7 equals -4, parentheses, and where we have this x, we know x is 3, minus 8, and so I can do 7 equals, let's see, -4 times 3, well that gives us -12 minus 8. Let's see, what is -12 minus 8? Well, of course that would give us -20. Ask yourself, does 7 equal -20? And of course the answer is no. So if I'm asking you which one of these functions will give me a y of 7 when x equals 3, in this case it's going to have to be f of x. Alright? Well, I hope these examples have helped you out. You have the next 5 problems, and I'll see y'all in our next video section.